Hello everyone, myself Harshita. Today my seminar topic is stationary process. Let's go over stationary process of random variables step by step. What is a stationary process? A stationary process is a collection of random variables in depth of time or space. That is x of t, t belongs to capital T. Here x of t is random variable at time t and capital T is time index. It can be discrete or continuous. So x of t represents how a random quantity changes over the time. Here the first order stationary process. Random process overview. A random process x of t is a collection of random variables indexed by time t. We study its statistical properties, mean, variance, correlation, and so on, etc. And what does order mean in stationarity? Here, first order. First order depends only on the first moment, that is mean, and second order depends on the first and second moments, that is mean plus autocorrelation. And higher order. Higher order involves higher moments or joint distributions. And the definition of first order stationary process. A process x of t is called first order stationary if it means if it if its mean does not change with the time, then e expectation x of t equals to mu is equals to constant for all t. That's it only cares about the mean being time invariant. Mathematically, for any time shift tau, expectation x of t is equals to expectation x of t plus tau. If it true, then first order stationary, or if it is false, if if expectation of x of t depends on t, then not first order stationary. Here the second order stationary process. Now we are discussing about what is a stationary order, what is a second order stationary process. A random process x of t is called second order stationary and also known as West's sense stationary WSS. If both its mean and autocorrelation are independent of time, it focuses only on the first two moments, that is mean is first moment and the autocorrelation is second moment. Mathematical definition of second order stationary. A process x of t is second order stationary if mean is constant. E of x of t is equals to mu, that is constant for all t. Autocorrelation depends only on time difference, that is Rx of T1, T2 is equals to Rx of T1 minus T2, that is Rx of tau, where tau is equals to T2 minus T1. Here the autocorrelation function ACF for a WSS process R x of tau is equals to expectation of x of t into expectation of x of t plus tau. It measures how the value of the process at time relates to the value at time t plus tau. And autocovariance function. The autocovariance function is Cx of tau, that is expectation of x of t minus mu into expectation of x of t plus tau minus mu. And for WSS, it is also depends only on tau. Properties of Rx of tau. For a second order stationary process, Rx of 0 is equals to expectation of x square of t. It is the average power of or maximum value. Rx of tau is equals to Rx of minus tau. It's an even function. Rx of tau less than or equals to Rx of 0. And finally, Rx of tau is equals to 0 for all tau not equals to 0. The process is white noise. A second order stationary process has expectation of x of t is equals to constant and Rx of t1 comma t2 is equals to Rx of t1 minus t2. Different types of stationary processes. The main two types of stationary processes. Sense stationary process and Waits sense stationary process. Strict sense stationary process. A process x of t is strict sense stationary if the joint distribution of x1 of t x of t1 comma x of t2 and so on x of tn is the same as that of x of t1 plus tau comma x of t2 plus tau and so on x of tn plus tau of any shift tau. Mathematically, fx of t1 comma fx of t2 son x of tn into x1 comma x2 comma son xn is equals to fx of t1 plus tau comma x of t2 plus tau and son x of tn plus tau into x1 comma x2 comma and son xn. That means that the meaning the full probability behavior is time invariant. Whitesand's stationary, Whitesand's stationary or weakly stationary. In practice, it's hard to check Stuxnet stationary, so we often use Whitesand's stationary, which only looks at first and second order statics. A process x of t is Whitesand stationary if mean is constant, then E expectation of x of t is equals to constant, that is mu. Autocorrelation depends only on time difference tau. Rx of t1 comma t2 is equals to Rx of t1 minus t2, that is Rx of tau. Autocorrelation function for a WSS process. Rx of tau is equals to expectation of x of t into x of t plus tau. It measures how the process values at different times are related. Here the conclusion of stationary process. Stationary process are random process whose statistical properties do not change with the time. This means the process looks the same at all time instants in terms of its probability behavior. Here the key points of stationary. Stationary ensures that the behavior of a random process is stable over time, making analysis and prediction and types of stationarity. First order stationarity. Mean is constant with the time. And second order stationarity. Mean is constant and autocorrelation depends only on time difference. That is lag. Stuck stationary Stuxnet stationary. All statistical properties or all moments or distributions are time invariant. Practical importance. Most real-world signals like speech, noise, or sensor data are exponentially makes sense stationary, and this assumption simplifies many analysis in signal processing, communications, and control systems. And the final conclusion, a stationary process is one whose essential characteristics like mean, variance, and correlation do not change with time. This stability all allows for consistent modeling and analysis of random signals and is a foundation concept in random process theory and signal analysis. Thank you. That's it.